All right, and for these last two problems on the worksheet, we have problems 7 and 8. So 7 says solve the system y is 2 to the x and y is 16 minus 2 to the x. All right, so go ahead and label this equation 1 and this equation 2. So these two equations now involve exponential expressions. So as we've seen in a few other problems, okay, since y is solved for in each equation, I'm just going to take this expression 2 to the x and substitute it in for y in equation 2. So equation 2 then can be written as 2 to the x is equal to 16 minus 2 to the x. All right, and so now I'm going to go ahead and solve for 2 to the x. So let's isolate 2 to the x. I'm going to move this 2 to the x uh, over by adding 2 to the x to both sides. And so on the left, I have 2 to the x plus another 2 to the x. So I have in total 2 of these 2 to the x's, or put another way, I have 2 times 2 to the x on the left-hand side. And then over here on the right, 16. So let's now divide both sides by 2. So I have 2 to the x is equal to 16 halves, so that's 8. And now 2 raised to what power is equal to 8? Well, 2 raised to the third power. So x is equal to 3. All right, and then to find y, that's where I'm going to plug 3 in for x into either equation 1 or 2. Equation 1 is quite a bit simpler, so I'll go with that. And so we have that y is equal to 2 raised to the third power, which is 8. So our ordered pair solution here is 3, 8, and that does it. All right, so let's go to the graph here. We have our equation y is 2 to the x here. Its graph is in red, and then y is 16 minus 2 to the x. That's here in blue, and I can see that these curves intersect. Yep, at that point, 3, 8. So it works. Nice. All right, and then for question 8, we have y is log x, and y is 10 minus 4 log x. So now we have logarithmic expressions as opposed to exponential. But we can approach this in pretty much the exact same way as we did for question 7. So I'm going to go ahead and start by replacing y in equation 2 with log x. So equation 2 can be written as log x is equal to 10 minus 4 log x. All right, so now let's go ahead and move the 4 log x over. So I add 4 log x to both sides. All right, and so then on the left, I have log x plus 4 log x. That's a total of 5 log x. And I have 10 on the right. So go ahead and divide both sides by 5 to get the log x on its own. And so this gives us the log of x is equal to 10 fifths. So that's equal to 2. And just keep in mind, this is a base 10 logarithm. So to solve for x, well, I'm going to take the base of 10 and exponentiate. So that's going to give me a 10 squared. And then that will equal x. So we get that x is 10 to the second power. Right? 10 squared is 100. All right, so that is our value of x for the point of intersection. So now let's find y in much the same way we did in question 7. So from equation 1, we have that y is just log x. So I want to take the log of 100. And again, this is a base 10 log. So 10 raised to what power is 100? Well, 10 raised to the second power is 100. And so y is 2. And so putting that all together, our ordered pair solution is 100, 2. All right, let's go check that out on the graph. So get rid of these here. So we have our log x curve in green, and then our 10 minus 4 log x curve in purple. So I'm going to have to zoom out here a little bit because our intersection point is supposedly way over here at the point 100 comma 2. So yeah, I can see that purple and green do intersect there. So it works. All right, well that is going to do it. Thanks so much.